Welcome to Colorado State University's podcast, The Audit, where host Stacy Nick talks with CSU faculty about topics ranging from their latest research to current events.
We've all heard the phrase, "don't eat the yellow snow." But with all the atmospheric contaminants out there, including forever chemicals from manufacturing facilities, heavy metals from car emissions, and microplastics from virtually everything, should we really be eating any snow? To find out, we spoke with Colorado State University snow hydrologist Steven Fassnacht. A professor with the College of Natural Resources, Fassnacht's research focuses on studying water availability by looking at how snow and related environmental factors change over time and across different locations. We asked him about what contaminants are making their way into snow and how and where to find the cleanest snow if you decide to partake on an icy treat. Really, should we be eating any snow?
We really should be looking at the snow, but visually that's often the marker, so don't eat the yellow snow. And for other obvious visual contaminants, things like dust and airborne pollutants and sand and things like that are pretty obvious. Needles, don't want to eat pine needles. But in terms of what you can find in the snow that you should really be concerned about, those are ones that we cannot see. So that is more of an understanding of where you are and what the sources of some of those contaminants could be. The big ones that we see around here are nitrogen and sulfur-based. So things that we call our NOxes, our nitrates, nitrites, and our SOxes, sulfates, sulfites, etc. And we have our phosphorus-based kind of equivalents as well. And these all come from emissions. They come out of the tailpipe, out of the smokestack, etc. So if you're downwind from a major industrial source of these, then the likelihood that you have these nitrogen, sulfur, etc. in the snowpack is a lot higher. There's a lot of physics and chemistry involved in what you get within the snowpack itself and where it comes from, etc. So, do you want to eat the snow? Maybe. And that's not an answer that people want to hear. They want to hear yes or no. And most of the time, you're probably okay. But you want to really be aware of where are you eating this snow?
As you mentioned, a lot of these are invisible to the naked eye, but things like dust, which can also be an issue, that's something that actually impacts snowmelt and runoff rates too, correct?
Dust on snow and other things that are dark on the snowpack really affect the melt rates. Here in Colorado, most of our snow melt is driven by the sun. We have 300 plus sunny days. We're here in Colorado because we love the weather. We know that from the sunburns we get because the sun's coming at us and is reflecting off the really shiny snow. But at the same time, then you add in dust, you add in ash, you add in black carbon that comes from industrial sources. And that lowers the reflectivity of the surface, right? How shiny it is. Technically, we call that albedo. Our snowpack here in Colorado, that melt is really driven by the albedo, by the reflectivity. And when we have dust coming in, that can lower it and make the snow melt a lot faster. The sources of dust are typically from the Four Corners area, the Colorado Plateau. So in northern Colorado, you see it a little less than you will in the San Juans, for example.
I guess shinier snow is better snow? Maybe?
Not necessarily. Shinier snow just is newer snow. Does that mean that it's better quality? Not necessarily. So if you have dust on the snow, that's going to be obvious. The snow, once it's on the ground, it's going to become less shiny because it's just changing. Think of the snowflake that you cut out when you were in kindergarten, that piece of paper, that delicate nature of snow. Well, the snow doesn't last like that for very long. It's going to end up being rounded, it's going to melt, so it may be less shiny, but still could be of good quality. And by that I mean you could still eat it without having a lot of contaminants in it.
We also talk a lot about microplastics and forever chemicals in our drinking water. I'm assuming that can also be found in snow.
Definitely. And that is a relatively new area that people have been exploring. We see all this in our water. We see things like caffeine. We see things like pharmaceuticals. Those make a bit more sense to be in our water because of our water treatment plants or people going to the bathroom outside, whereas on the snow, it's a little bit different in terms of pharmaceuticals, things that go through the human body. But we can have microplastics, we can have other forever chemicals. It depends on how they get there. So that is part of the process as well. Some of these, we typically think of dust and fine particles are in the clouds when those snowflakes are forming. And so that's the core of the snowflake that's coming down. But then as the snow falls, because think of the snow again, it's your kindergarten cut out of the piece of paper and all those different angles and all those shiny bits, well, that means that the snow has a lot of surfaces. If you compare that to rain is a ball, and the snow has many more surfaces. And so when it falls through the atmosphere, when it falls from the clouds to the ground, it can then pick up a lot more particles that are in the air. So if you have anything that's airborne, you have dust. I think about the Cameron Peak fire of 2020 and how yellow and brown the air was. If you had rain, and even more effectively, if you had snow that was falling, it would wash all of those things out of the air, and that then ends up in our snowpack.
Then how do forever chemicals and microplastics get into snow?
That is not exactly known. The microplastics, there's so many little bits and pieces of plastic that are around. We had the huge issue and still have the huge issue of the garbage island, the plastic island floating around the Pacific. Well, that's big chunks of plastic. But microplastics can be anything. And just think of all the plastic we have in our lives, and it can break off with whatever, and you get these little tiny bits. Well, they're pretty light, and so they can easily end up in the air. Do you have a big cloud of microplastics? Probably not. But do you have those microplastics in the air? Sure. They come off of tires. They come off of car parts. They come off your Gore-Tex coat, etc. There's lots of sources. Think about going out in the snow. You've got plastic ski boots on and plastic skis and poles, and your jacket and all of your equipment. That's plastic. Any breakdown of that, which will happen over time, is going to put microplastics onto the snowpack. So where do we have microplastics? Well, probably lots of places. Where do they come from? It's not quite as obvious as a big smokestack and something being blown downwind.
What about the effects that those kinds of contaminants can have on the body when ingested? So if you're eating snow, I'm guessing you have to eat a lot of snow to have it have an impact, but what could that possibly mean?
Our snow in Colorado is still good quality. We don't have huge industrial sources that are bringing in all of these contaminants. So can we eat the snow? Probably. What does that mean? Usually not very much. The plastics, the microplastics, they tend to just go through your body or they bioaccumulate, but it's not like mercury in a big fish. These are things that are not as hazardous, at least as far as we know now. I'm not a microchemist. I don't know the specifics. I'm not a microbiologist. I don't know how this actually will impact the body, but if you don't have many, then it's going to be a bit less of a hazard. Doesn't mean you're not going to have them. If you're going to go out and eat snow all the time and have that as your water source, then you want to think about how you can filter some of these things out. Microfiltration is one of the good methods of taking out a lot of these constituents, but you need to know what's in there before you need to know what to take out.
I recently saw a video on social media of a woman from the Appalachian region, and she was making snow cream. which was a dessert made by mixing snow with milk, sugar, and vanilla. And she made a point that it needed to be fresh snowfall. But I'm wondering, one, is that a good idea? And two, does that really fresh snowfall make that much of a difference? If it's her point was that it needed to be really fresh, like within the last hour or so.
That's not going to make a difference. I'm now familiar with that snow cream. I was out in the field last winter with some students, and one of the students brought a big bowl and brought some powdered sugar and some condensed milk. I don't remember the vanilla part of it, but I'm sure you could add that. And it was really tasty. Are you eating gallons and gallons? No, because think about the brain freeze, the ice cream headache you would have if you ate gallons and gallons of that, and how much sugar there would be in there. But getting back to the snow itself, to me, it would be more of a texture issue. And the texture of fresh snow, the characteristics, the shape of that snow compared to older snow. And it's just a bit more fun, and it's a bit more joyous and festive. And, this doesn't have to be a holiday thing, but being out in the woods and eating some of the snow, it just feels better to go, I have some fresh snow, this light fluffy powder. But from a contamination perspective, it's not going to make that big a difference. If you think about the density of fresh snow is much less than of older snow, we think of the really light fluffy powder, the stuff you can blow off your hand, blow off your windshield, and it's going to be a lot less dense. And because of that, you're not necessarily having as much contaminant per unit mass, so to speak, but how much are you going to eat? You're probably mass-wise eating this fresh snow. It's a texture, it's a feel thing, and chemical-wise, it's not going to change anything.
So there's not like a strata where you want to eat the top layer of snow versus the middle layer of snow versus near the bottom. Contaminants don't sink.
Well, the dissolved contaminants do get washed through the snow. So our nitrogen, our phosphorus products, etc., sulfur products, those actually, when the snow starts to melt, those get washed out first. And so if the snowpack is melting, those actually appear in the stream, and you see this big pulse of whatever's in the snowpack. Any of the larger particles that don't dissolve, our sand, our dust, etc., those stay within the snowpack. And what actually happens is the snowpack will melt down to them. So we have a big dust storm in March that covers the landscape. Well, if we're high enough up, we'll get multiple snowstorms after that, and that'll cover that dust layer. But then as the snow melts, it melts down to those physically visible layers. So we get accumulation that way, but are you going to be eating that snow? Not really. So yeah, later in the season, and maybe this goes back to the woman's idea of eating fresh snow, it's not going to have that accumulation where you've combined different layers of dust and whatnot.
Better or worse from an atmospheric contaminant perspective, catching a raindrop on your tongue or a snowflake?
It's likely that the raindrop is going to be cleaner than the snow, but it depends what's in the air. It depends on what was in the clouds when the raindrop versus the snowflake formed, and then what is below the clouds. So if it's a nice clean day and you don't have a lot of chemicals in the air, then it doesn't really matter because you're not pulling out those chemicals when it's raining or when it's snowing. So I can't give you a solid answer. The conditions of what's in the air are going to be a function of the temperature, things like that. Think of the Front Range and think of when do we have the haze, when do we have that brown cloud. There is some seasonality to it, so I'd be aware of that. I'd more look around and think, what were the conditions when these clouds were forming, and what's in the air?
Does it have anything to do with, and you mentioned this earlier, that kind of going back to that kids cutting out the snowflake, the raindrop is the ball and the snowflake has a lot more area surface to pull from? Does that have anything to do with it?
Yes. So think of a ball. A ball is round and doesn't have a lot of surface area to mass. A polar bear is a big round ball of fur with legs so that they minimize how much heat loss they have. And then if you think about the raindrop, that's the same thing versus a snowflake, which is a millipede because it has all of these different arms. Bad analogy, but I think you know where I'm going. And just a lot more area per unit mass, orders of magnitude, 100-fold, maybe even 1,000-fold, depending on the intricacy, how ornate the snow is. And so if there are things in the air, there's just more surfaces to then pick up whatever those chemicals are. But if you don't have the chemicals in the air, if you're in a clean atmosphere, then it's not really a problem. The physics of what happens and then adding in the chemistry gets really complicated. So you can have snow forming in the clouds, but then if it falls through a warm atmosphere, then it's going to melt. So it's going to start as snow but end up as rain. So is that different than if that snow didn't melt and you caught it with your tongue? Probably not. Again, depending on what it falls through. You can have the opposite too if you had rain forming in the clouds and then it freezes. So if you have an inversion where the ground is colder than the air, which doesn't happen that often, then it would freeze. But that's the same as hail. Do you want to be capturing balls of hail on your tongue? Probably not.
Ouch. I don't think so.
I don't think so either.
Now, do you eat snow? And if you were going to, where would you go to eat snow? Where would be the safest, cleanest snow?
I would go further away from the Front Range because we have the Front Range. We have a lot of people living here. We have a lot of industry. And if the wind is blowing up the hill, which we often get upslope events where they're coming from the east and blowing up the hill, then that's going to be bringing those chemicals into the air and into our snowpack. And research from Niwot Ridge behind Boulder, research from Loch Vale and Rocky Mountain National Park has shown that there's elevated nitrogen, NOxes, and SOxes are sulfur constituents there because they are not all year round, but part of the year round. They're downwind from these industrial sources, from the cars, from where all the tailpipes and the smokestacks are. And so I would shy away from areas like that. Can you eat a handful of snow? Yes. Do you want to subsist on snow coming out of the tailpipe of your car? No. So if I were to go and pick a place, I'd go further away from industrial sources. I wouldn't go right to the side of the road because you have tailpipes. Hike in 100 feet or 200 feet where you're a little bit further away.
Now, do you eat snow?
I do eat snow. I take a lot of water with me when I'm out in the field, but I'll eat a handful of snow. Yeah, I'll eat the fresh snow, and it's a texture thing. That density, the fresh snow is so light that you can take a handful and you're not getting a lot of water. Realistically, if you want a lot of water, you should stick your hand into the snow and get the older, rounder snow because you'll have a lot more water for a handful than you would for fresh snow.
As a snow hydrologist, does your line of work change how you see snow now? Maybe while the rest of us are thinking about skiing or sledding or even shoveling, are you calculating snowpack properties and thinking about runoff rates? And does knowing so much about snow ruin the magic of it for you?
There's a different magic. There's the science magic. There's the curiosity. There's the questions. During the pandemic, I had told my spouse that I was going to shovel off the deck, and she was looking for me a few hours later, and only half the deck, and the deck is 10 by 10 feet. Like, this is pretty small. Only half the deck was actually shoveled off because I was on my hands and knees measuring the properties because there were some really interesting melt features, and I wanted to look at how the density, how that amount of water changed because you had preferential melt and there were certain areas in the shadows. And so, yeah, I'm looking at snow from a science perspective, but there's the curiosity, maybe not magic, but the curiosity. So I spend a lot of time enjoying the snow, but from a different perspective than other people.
Well, now I think our listeners will probably be looking at it from a different perspective, too. Steven, thank you so much for your time. I really appreciate it.
Yeah, you're welcome. Thanks for chatting with me.
That was CSU snow hydrologist Steven Fassnacht speaking about the contaminants found in snow. I'm your host, Stacy Nick, and you're listening to CSU's The Audit.